Hi, it's Detangler with your daily Detangler, and I want to talk today about collaborating together. When it comes to collaborating together, what's working well on the team? Well, first, we collaborate with purpose. We have discipline when we collaborate, and we view collaboration as a process, not as a role or as a mandate or as a skill. For example, we don't say we are collaborators. We say we have different roles. We don't say I have collaboration skills, for example. And we view collaboration as a way in which to work. We help each other out by understanding where each person is and also where we need to be going. So, for example, I was talking with um, Tester yesterday about another relationship or another account that we have, and just trying to figure out one, what needs to happen from the customer's perspective as they have discussions, and then two, what do we need to do next? That's an example of collaboration. And so we're going to talk about that and also how it helps each other be successful. So what works? Well, when you focus on having a purpose, when you focus on the why, and not only the first, cursory why, but the why behind the why behind the why behind the why. If anybody's taught to Catalyst, you know what I mean. And also, why are we focused on what we're doing? I think this is an interesting discussion, and something that I've learned a lot about is this idea of why are we even having a conversation in the first place. Another thing that's working well is having space for the discussion. Another thing that's working well is understanding and unpacking the implications of why we're focused on what we're doing and why it's important to do what we're doing. Another thing that works well is having discipline. We've talked a lot about the speedy system and also having discipline in the context of the meetings that we're having and also the information flow. If we think about the information that's being exchanged between each other, having discipline there to stay scoped in and also tight as to what's happening and when. That information that we have and the discipline that we have around sharing information, for example, it's in context of what's happening between people, between the conversations that we're having with each other and the conversations that we're having with our customer. We're also customer focused, not so much on what it means to us, but what it means to our clients in the end state. And then it's also in the flow of work. And when we're moving so fast, it's hard to collaborate if you're not in the flow of work. For example, there was some experience stuff that Catalyst put out on Friday. Today is Tuesday. I almost feel like it would be totally disruptive to go back and chime in on that, even though there was a weekend in between. So the speed at which things are moving and the speed at which we collaborate is an important consideration to keep up momentum. Another thing that works is the process. Here we have a 3D cube. That cube is starting in a very fragmented state through the context of working together and the environment of working together. The cube can actually become more clear and more concrete. So that concept to concrete process, which we're calling the speedy system, that speedy process can be followed to help us collaborate. It also can help figure things out, and it also can help us get things done. And so if you think about it, there's this continuum of figuring stuff out and getting stuff done. And that's where collaboration happens. There's a collaboration process to figure stuff out on the left side and make sense of all the fragmentation. And then there's a collaboration process on getting stuff done on the right side where we have something more concrete. These continuums of conceptual to concrete create an interesting challenge for collaboration that our team is working through on a daily basis. One of the things that I'm responding back to is the overall account planning piece, where we have the green sheet. We turned it into a playbook, and there was a discussion around how to use it, which is on the get stuff done side. But then there's a conversation around figuring out what to put in there. And then there's a discussion around how do we stage this out for our customers who are going to be really anchored into wanting to have something concrete on the far right side versus something conceptual. I was also talking to a colleague of mine, and she was talking about her feedback that she got of being an orchestrator, and the discussion was, look, we don't have time for conceptual. We have to get stuff done. So it's perceived that conceptual isn't related to getting stuff done, but that's not necessarily true. So what do I mean by that? Well, if you think about collaboration, let me introduce you to a concept of the Scott therapy tool. When you think about collaboration, we often think about collaboration as brainstorming or as doing one type of work to synthesize what's going on and create new insights. For example, that would be on the left side of the cube. You can also think about collaboration as to how do we engineer it? How do we create the piece parts or the components of what we're talking about and structure those components to figure out what should be in our cube? And then we should maybe collaborate around how to test this out. Collaborate to figure out what to test it and how to test it and who to test it on. That's collaboration as well. Then there's collaboration on how do we relate this to other people. How do we take what we've learned? How do we communicate and relate to others? That's a whole collaboration process too. For example, role playing, creating a discussion that models the reality. And then finally, the transfer of an idea or a concept or something new to somebody else, that's collaboration too, in order for it to stick and for it to be adopted. So each of these are 5 different types of collaboration. The reason why this is important is we often show up as salespeople trying to figure out how to sell it. I've heard phrases of I can't sell this concept. I don't know how to communicate it. I need to know how to sell it. Well, perhaps somebody's in the level 2 here, collaboration, where we're trying to engineer what the components are. What are the piece parts of the speedy system, for example? Thinking about a recent example. How do we synthesize what the scope of the speedy system is? Layer 1. How do we go to take the components of the speedy system on the tennis court? That's layer 2. How would we test the speedy system in a webinar and building a webinar? That's layer 3. How would we explain the speedy system to a client? Not just for them to understand and make it concrete. And then layer 5, how would we actually sell the fact that our speedy system is a competitive advantage? Each of these is a completely different layer of collaboration, and all are collaboration, which means 2 people or more come together to create something new. That collaboration, where we leverage each other's perspective, it's in that agitation and in that work where things become more clear. We're wired as salespeople to think everything is a layer 5 and completely done. However, a lot of what the work is and the competitive advantage of being consultants is going through 1, 2, 3, 4, 5 in that type of flow, not from a 5, 4, 3, 2, 1 perspective. So if we figure stuff out, that's a figuring it out bias versus a getting stuff done bias on the left side. And these 2 things can be colliding. And I think that's an important piece that we're figuring out as we learn to work on so many things at once. Not only are we working on different collaboration paths, it's really interesting to think about all the different concepts that we're working on in flight together all at one time, whether it's how to position account planning, how to figure out how to land a new deal, how to land a concept of a green sheet, how to figure out what to put in a keynote, what to put in a webinar. All of these are layers of collaboration that are unfolding as we work together. And creative people like us, we all work on these all at one time, and we need discipline, we need focus, and we need the ability to follow the process in order to stay aligned. So this aligns to, in my view, principle 7, which is about getting it right, not being right. In order to get it right, it's to understand the architecture of collaboration and all the different types of layers in the Scott therapy tool. When you think about that layers of collaboration, which I jokingly call the Scott therapy tool, it's focused on figuring out how to get it right, not being right. And the reason why this is also important, and the so what of it is, if you think about what we build and how we build it, it's a lot of iterations over time. That's important to consider because the big breakthroughs that we would have are done in the context of the work we do. For example, a soda can, a simple soda can. If you think about a soda can, you think something simple. You think something that's a given. You think something that's incredibly easy. But did you know that there's so much engineering that was created in order to figure out what a soda can or should look like? There are actually a sub-process here of 11 steps, 11 steps just to shape the soda can itself. That's like one layer of our collaboration paths that I just mentioned. I mentioned 5 layers. In this case, pretend that layer 3 has 11 steps. That's what this means. So a soda can actually required a lot of collaboration, a lot of creativity, a lot of focus, a lot of discipline, and obviously following the process. If this is enough for you, you can stop the video now, but I'm actually going to show this video. I think it's fascinating. on how the soda can is created. And what I want you to think about if you choose to continue this is think about the way in which this was finally brought to market, layer 5. Think about this is layer 5 where we're transferring and we're selling a soda can. But think about all the steps that likely happened in 1, 2, 3, and 4 to get the soda can to the point where it's now. And it's probably taken hundreds of years. I didn't look it up, but it's probably taken 20 to 100 years to figure out the shape and size and how the soda can works. It's fascinating when you watch this video. I hope you enjoyed the video, and I hope you enjoyed thinking about collaboration. So let's get to it.
The ingenious design of the aluminum beverage can. Every year, nearly 500 billion of these cans are manufactured. That's about 15,000 per second. So many that we overlook the can's superb engineering. Let's start with why the can is shaped like it is. Why a cylinder? An engineer might like to make a spherical can. It has the smallest surface area for a given volume, and so it uses the least amount of material. And it also has no corners, and so no weak points, because the pressure in the can uniformly stresses the walls. But a sphere is not practical to manufacture, and of course, it'll roll off the table. Also, when packed as closely as possible, only 74% of the total volume is taken up by the product. The other 26% is void space, which goes unused when transporting the cans or in a store display. An engineer could solve this problem by making a cuboid-shaped can. It sits on a table, but it's uncomfortable to hold and awkward to drink from, and while easier to manufacture than a sphere, these edges are weak points and require very thick walls, but the cuboid surpasses the sphere in packing efficiency. It has almost no wasted space, although at the sacrifice of using more surface area to contain the same volume as the sphere. So, to create a can, engineers use a cylinder, which has elements of both shapes. From the top, it's like a sphere, and from the side, it's like a cuboid. A cylinder has a maximum packing factor of about 91%, not as good as the cuboid, but better than the sphere. Most important of all, the cylinder can be rapidly manufactured. The can begins as this disc called a blank, punched from an aluminum sheet about 3/10 of a millimeter thick. The first step starts with a drawing die, on which sits the blank and then a blank holder that rests on top. We'll look at a slice of the die so we can see what's happening. A cylindrical punch presses down on the die, forming the blank into a cup. This process is called drawing. This cup is about 88 millimeters in diameter, larger than the final can, so it's redrawn.
This is
The
like
ingenious design.
This is like our step 1 of our collaboration process, right? And then, so I won't interrupt again, but we're basically starting, what he's doing is he's starting with step 1 of our collaboration process, and it'll get all the way to step 5.
Sheet about 3/10 of a millimeter thick. The first step starts with a drawing die, on which sits the blank and then a blank holder that rests on top. We'll look at a slice of the die so we can see what's happening. A cylindrical punch presses down on the die, forming the blank into a cup. This process is called drawing. This cup is about 88 millimeters in diameter, larger than the final can, so it's redrawn. That process starts with this wide cup and uses another cylindrical punch and a redrawing die. The punch presses the cup through the redrawing die and transforms it into a cup with a narrower diameter, which is a bit taller. This redrawn cup is now the final diameter of the can, 65 millimeters, but it's not yet tall enough. A punch pushes this redrawn cup through an ironing ring. The cup stays the same diameter as it becomes taller and the walls thinner. If we watch this process again up close, you see the initial thick wall and then the thinner wall after it's ironed. Ironing occurs in 3 stages, each progressively making the walls thinner and the can taller. After the cup is ironed, the dome on the bottom is formed. This requires a convex doming tool and a punch with a matching concave indentation. As the punch presses the cup downward into the doming tool, the cup bottom then deforms into a dome. That dome reduces the amount of metal needed to manufacture the can. The dome bottom uses less material than if the bottom were flat. A dome is an arch revolved around its center. The curvature of the arch distributes some of the vertical load into horizontal forces, allowing a dome to withstand greater pressure than a flat beam. On the dome, you might notice 2 large numbers. These debossed numbers are engraved on the doming tool. The first number signifies the production line in the factory, and the second number signifies the body maker number. The body maker is the machine that performs the redrawing, ironing, and doming processes. These numbers help troubleshoot production problems in the factory. In that factory, the manufacturing of a can takes place at a tremendous rate. These last three steps, redrawing, ironing, and doming, all happen in one continuous stroke and in only a seventh of a second. The punch moves at a maximum velocity of 11 meters per second and experiences a maximum acceleration of 45 Gs. This process runs continuously for 6 months, or around 100 million cycles before the machine needs servicing. Now, if you look closely at the top of the can body, you see that the edges are wavy and uneven. These irregularities occur during the forming. To get a nice, even edge, about 6 millimeters is trimmed off of the top. With an even top, the can can now be sealed. But before that sealing occurs, a colorful design is printed on the outside. The term of art in the industry is decoration. The inside also gets a treatment. A spray-coated epoxy lacquer separates the can's contents from its aluminum walls. This prevents the drink from acquiring a metallic taste and also keeps acids in the beverage from dissolving the aluminum. The next step forms the can's neck, the part of the can body that tapers inward. This necking requires 11 stages. The forming starts with a straight-walled can. The top is brought slightly inward, and then this is repeated further up the can wall until the final diameter is reached. The change in neck size at each stage is so subtle that you can barely tell a difference between one stage and the next. Each one of these stages works by inserting an inner die into the can body, then pushing an outer die, called the necking sleeve, around the outside. The necking sleeve retracts, the inner die retracts, and the can moves to the next stage. The necking is drawn out over many different stages to prevent wrinkling or pleating of the thin aluminum. Since the 1960s, the diameter of the can end has become smaller by 6 millimeters, from 60 millimeters to 54 millimeters today. This seems a tiny amount, but the aluminum can industry produces over 100 billion cans a year, so that 6 millimeter reduction saves at least 90 million kilograms of aluminum annually. That amount would form a solid cube of aluminum 32 meters on a side. Compare that to a 787 Dreamliner with a 60-meter wingspan. Now, after the neck has been formed, the top is flanged. That is, it flares out slightly and allows the end to be secured to the body, which brings us to the next brilliant design feature, the double seam. On older steel cans, manufacturers welded or soldered on the ends. This often contaminated the can's contents. In contrast, today's cans use a hygienic double seam, which can also be made faster. This can is cut in half so you can see the cross-section of the double seam. To create this seam, a machine uses two basic operations. The first curls the end of the can cover around the flange of the can body. The second operation presses the folds of the metal together to form an airtight seal. While the operations themselves are simple, they require high precision. Parts misaligned by a small fraction of a millimeter cause the seam to fail. In addition to the clamping of the end and can body, a sealing compound ensures that no gas escapes through the double seam. The compound is applied as a liquid, then hardens to form a gasket. The end, attached immediately after the can is filled, traps gases inside the can to create pressures of about 30 psi or 2 times atmospheric pressure. In soda, carbon dioxide produces the pressure. In non-carbonated drinks like juices, nitrogen is added. So why is a beverage can pressurized? Because the internal pressure creates a strong can despite its thin walls. Squeeze a closed, pressurized can, it barely gives. Then squeeze an empty can. It flexes easily. The can walls are thin, only 75 microns thick, and they're flimsy. But the internal pressure of a sealed can pushes outwards equally and so keeps the wall in tension. This tension is key. The thin wall acts like a chain. In compression, it has no strength, but in tension, it's very strong. The internal pressure strengthens the cans so that they can be safely stacked. A pressurized can easily supports the weight of an average human adult. It also adds enough strength so that the can doesn't need the corrugations like in this unpressurized steel food can. Well, initially pressurized to about 2 atmospheres, a can may experience up to 4 atmospheres of internal pressure in its lifetime due to elevated temperatures, and so the can is designed to withstand up to 6 atmospheres or 90 psi before the dome or the end will buckle. Why is there a tab on the end of the can? It seems a silly question. How else would you open it? But originally cans didn't have tabs. Very early steel cans were called flat tops for pretty obvious reasons. You use a special opener to puncture a hole to drink from and a hole to vent. In the 1960s, the pull tab was invented so that no opener was needed. The tab worked like this. You lift up this ring to vent the can and pull the tab to create the opening. Easy enough, but now you've got this loose tab. The cans ask you to please don't litter, but sadly these pull tabs got tossed on the ground where the sharp edges of the tabs cut the bare feet of beachgoers or they harmed wildlife. So the beverage can industry responded by inventing the modern stay-on tab. This little tab involved clever engineering. The tab starts as a second-class lever. This is like a wheelbarrow because the tip of the tab is the fulcrum and the rivet the load. The effort is being applied on the end. But here's the genius part. The moment the can vents, the tab switches to a first-class lever, which is like a seesaw, where the load is now at the tip and the fulcrum is the rivet. You can see clearly how the tab, when working as a wheelbarrow, lifts the rivet. In fact, part of the reason this clever design works is because the pressure inside the can helps to force the rivet up, which in turn depresses the outer edge of the top until it vents the can, and then the tab changes to a seesaw lever. Looking from the inside of the can, you can see how the tab first opens near the rivet. If you try to simply force the scored metal section into the can using the tab as a first-class lever with the rivet of the fulcrum throughout, you'd be fighting the pressure inside the can. The tab would be enormous and expensive. If you'd like to learn more about the entire life cycle of the aluminum can, watch this animated video by Rexam that describes can manufacturing and recycling. A typical aluminum can today contains about 70% recycled material. Also, Discovery's How It's Made has some great footage of the manufacturing machinery. Here are 2 different stepwise animations of the entire can forming process. And lastly, these are 2 detailed animations of the cup drawing and redrawing processes. The aluminum beverage can is so ubiquitous that it's easy to take for granted. But the next time you take a sip from one, consider the decades of ingenious design required to create this modern engineering marvel. I'm Bill Hemmick, the Engineer Guy.
So when you think about it, if you're still here, the can itself goes through 5 steps, but think about the 5 steps as it unfolded over time to even come up with that can. And then finally, think about the video and the production of this video to create this video. I don't know if you saw it, but it was pretty much one continuous take. When you look at the stages, how they created it, the cut-ins, all of that, it's a great level 5 video to transfer the idea of a can to us. But if you think about all the collaboration that happened to build it, it went through the idea, the engineering of the video, the testing, probably the mock-ups and storyboarding of the video, and then how to figure out how to relate these concepts, where to draw in the animations of the wheelbarrow, where to figure out how to explain why decoration is important, things like that. So the focus may be on how do we get to transfer this video over, but the can video itself likely had to go through these 5 layers of collaboration. So this is something to think about as you collaborate with others. If you stuck with it for this whole time, I appreciate it. This is a little bit longer as an option for you. I'll see you on the next one. As always, this is the Detangler, and Detangler out.